All right, this is the Algebra 2, Unit 3, Lesson 4 video over multiplication of matrices. So this is where we're multiplying two matrices by one another. And so the first kind of concept that you need to understand is when you are able to multiply matrices by one another. And it's kind of buried here in the text, but basically, in order to multiply two matrices by each other, the first matrix has to have the same number of columns as the rows of the second matrix. So I've already got an example here, so you can kind of see what I mean by that. So here I have a 2 by 3 matrix in the first, and the second matrix is a 3 by 3 matrix. So these two matrices, if I wanted to multiply them, or if I wanted to know if I could multiply them, I'm going to look up here at the top where it says the number of rows and columns. So remember that the matrix is rows times columns, rows times columns. And so when we look at this, the columns of the first matrix have to match the rows of the second matrix. So in other words, when I write it like this, if I look at the inside numbers, if they are the same, then yes, I can multiply them. Well, then what does that tell me about the answer matrix? What is the answer matrix going to look like? Well, whenever I have this compatibility and I find this, those numbers don't come into play. It's only what was left. So the answer matrix is going to be 2 by 3, and that's where I'm getting those answers from right there. Actually going to do that in a different color so that it makes a little more sense. So again, I have a 2 by 3 matrix. So my answer matrix is going to be 2 by 3. So that's the first piece of information you need is how to know when matrices are compatible. And it's when the columns of the first matrix equal the rows of the second matrix. All right. So the way this is going to work is we are going to multiply each row times each column. So the way that looks, the way it's going to look at the end is basically in my answer matrix, I'm going to write kind of a little code in a sense to tell you what you're going to multiply. So in the first position, you're going to do row 1 times column 1. Row 1, column 2, and row 1, column 3. So notice row 1 answers go along row 1 in the answer matrix, and column 1, column 2, column 3. So the rows and column numbers tell you what position they go in. So again, this is going to be row 1, row 2, column 1, column 2, column 3. So then obviously in the bottom, it's going to be row 2, column 1, row 2, column 2, row 2, column 3. So these are telling me what to do to find the answer for that item or element in the matrix. So now it does get a little bit complicated from here, because what we then have to do is we have to then multiply each element from row 1 times each element in column 1. And that's going to give us the answer here. So let me show you what I mean by that. So again, we're going to start by doing row 1, column 1. And it's going to equal, again, row 1 is this row, column 1 is this column. So I'm going to do 1 times 4 plus 0 times 6 plus, move this into a place that's not in the way, plus 4 times 0. So notice I did first term times first term, second term times second term, last term times bottom term. So that's how you do it. You do like position 1, position 2, position 3. And then you find those answers. So 1 times 4 is 4, plus 0 equals 4. So in row 1, column 1, I put a 4. Then I move on to row 1, column 2. Okay, so a lot of this is going to be the same. So it's going to be 1 times, and then let me erase. Now I'm doing column 2. 1 times 2. Let me just fix that. That doesn't look like a 1, does it? 1 times 2 plus 0 times 1 plus 4 times 2. That's going to be 2 plus 0 plus 8, and that gives me 10. So 10 goes row 1, column 2. And then we keep going. Row 1, column 3. Again, I'm going to use the same numbers for row 1, but now I'm going to move to column 3. So I have 1 times negative 1 plus 0 times 0 plus 4, oops, sorry about that, 4 times negative 3. So I end up with negative 1, 0, and negative 12 for negative 13 as an answer. And that's what goes over here. So you can see this takes quite a bit of work to get all the way to the end. I'm going to take this stuff here, and I'm actually going to move it down out of the way so that I can do some more work up here without having to go away from the actual matrix. So I'm going to erase those, and now we're going to do row 2. So we're going to do row 2 times column 1. So here we go, row 2, column 1. That's going to be negative 2 times 4 plus 3 times 6 plus negative 1 times 0, negative 8 plus 18 plus 0 is 10. So then I move on to my next row. Let's get rid of that. Oops. Let's get rid of that and go row 2, column 2. And that's going to be here. So I go negative 2 times 2 plus 3 times 1 plus negative 1 times 2. Negative 4 plus 3 minus or plus negative 2. That's going to be negative 6 plus 3 is negative 3. Goes right there. And then I go down to my last one, row 2, column 3. Negative 2 times, let's jump up here and look at our last column, which is going to be column 3 right here. So negative 2 times negative 1 plus, let's see what that is, 3 times 0 plus negative 1 times negative 3. So we end up with 2 plus 0 plus 3, because those negatives all cancel out, giving me 5. And so you can see the amount of work required to get the multiplication of a matrix. But I just want to drive this point home. You're going to do each row times each column. So you'll see all the work down here. And the position of row and column kind of matches up. So row 1, column 1 answer goes in row 1, column 1 of the new matrix. Row 2, column 3 answer goes in that position in the new matrix. So it kind of helps you stay organized if you kind of write it out that way. All right, so that's a lot of work for one problem, but you'll see the ones in the unit are not quite as difficult. They ask some vocabulary questions, conceptual questions in number 1 and number 2. You just answer here, yes or no, can they be multiplied? So you need to go back to what I said about how to determine if they can be multiplied. Remember, it has something to do with the columns and rows being compatible. Yes or no on 3 and 4. And then number 5, multiply. Well, this only has one row and one column. So actually, that one should be very easy for you. So I'll let you kind of go through that. That's not going to take a whole lot of work at all. A little bit more work on number 6. These are both 2 by 2 matrices. So it will take about 4 steps to get the answer. And then number 7 is a 1 by 3 and a 3 by 3. So your answer is you're only going to have to do 3 answers on that one as well. So again, follow my example there. first determine what the answer matrix is going to look like. Remember, like this one is going to be 1 row, 3 columns, and then 3 rows, 3 columns. So those are going to be yes. And the answer matrix, just to get you started, is going to be a 1 by 3 matrix. So your answer is just going to be 3 terms. So you should be able to get that one pretty easily. In fact, all of these take a lot less work than the example that I gave you. All right, that's it for multiplying matrices. And that is it for this week. The next time I'll post videos will be on the after the Thanksgiving break.